Okay, I'm very pleased to announce Carole, who's giving our keynote. I think Carole has a unique perspective, having worked in this area for so long, and can really run us through how this all originated and where we're hopefully heading in the future.
Thank you very much. So I was asked to give this talk at the end, when you're actually sick to the back teeth of FAIR. So that's a bit odd, and there's quite a few things that we've talked about in the meeting, which I think, oh yeah, that's in that slide as well. So in some senses, it's a sort of summary of what we've been talking about, and in other senses, it's just me rambling. So we'll see how it goes. So what are we going to do? FAIR history and the future. So FAIR history, we had several people in this room, including Eric and others, were there at the 2014 meeting in the Lawrence meeting in the Netherlands, where there was lots of brainstorming. There was a biohackathon afterwards, which Mark was at, which really devised and sort of settled down some of the principles. There was a Force 11 group set up. Then there was a paper, which, by the way, had 8 US people on it. It isn't just a European paper. It was a lot of drinking. That's very important to remember. So this was people thinking about and bouncing around ideas. Since then, it's all gone a bit bananas. So we got government agencies and policies and documents and the turning FAIR into reality activity and new rules from the NIH policy about FAIR. We've got an entire industry on now writing FAIR guiding principles for different kinds of disciplines, for molecular plants and for computational biology and for the pharma community and for all sorts of other places. We've also got the Research Data Alliance, of course, but a load of activities and different projects which have FAIR and a noun or FAIR and a verb associated with them in the generation of a project algorithm. We also have a whole bunch of activities going on with evaluation services and manual evaluation services and evaluation businesses and FAIR evaluations announced and so on. So it's really kind of created this huge kind of energy and industry that we already mentioned extensively today, the Research Data Alliance maturity model, which is actually, by the way, a PricewaterhouseCoopers activity as a contract to the Commission. So this is, it might look like a grassroots, but it's not. It's a Commission activity in order to be able to decide how they will judge data sets in order to become whether they are fair or not. So that kind of matters. So why did this all happen? It's a rallying call. Be kind, be fair, be honest. And somebody just said, who can object to fairness? It's like objecting to love or peace. So it had a very strong rallying call. Okay, so why? What happened? Well, we had a fairy godfather who is Barrett. And so he not only embarrassingly coined the term, and I say embarrassingly because I'm a native English speaker and he's Dutch, and he came up with a better word than we had previously used, which was actually understandable by politicians. Terribly important. You can say to a politician, we should make our data fair for everybody, and they go, oh, that sounds good. And so, whereas before, we were overcomplicating the story. Of course, this causes some difficulties because it is a complicated story. So we simplified it in order to be able to sell it and to get this rallying call. But actually, when you begin to put boots on the ground, of course, you notice it is much more complicated than that. A very important piece, though, is that this coincided with the European Open Science Cloud activity. So this was a very important driver. So it isn't just it was fair, it was also at the same time there was a number of public activities really driving the need in order to be able to assemble data, assemble data objects, assemble all kinds of resources into the notion of a shared commons. And the European Open Science Cloud is actually a shared commons. So one of the important things that I think made it a success was not just the groovy name and not just the fuzzy feeling, but also the fact there's this very strong driver. community data commons. We already heard about from Philippe about the NIH commons that's emerging, but there's also the commons that we're developing in Europe. For example, the European Open Science Cloud Life project, which Elixir is one of the leaders of, is actually a commons of commons. And the only way it's going to really work is if everything operates in a fair way, if there's fair communication between the different, the catalogue zoo, the resource zoo that we have there. And here we're talking about commons, where it's a governed shared space for digital objects for a community. It's not a lake and it's not a warehouse, it's a commons. The other thing that's in the paper and part of our early activities was about fair digital objects, not just data. So we also talked about a fair digital object framework, which has what minimum metadata and identifier services do we need. And here's I don't know if Ted is still here. Is Ted still here? Yeah, there's Ted. You probably can't see him, but that's Ted. And I made a big sign just in case you didn't spot it, pointing to the fact that this is actually from the Lorentz meeting. This is a slide shot of pointing out the hourglass idea of we need minimum types of services so we can maximize the services that can support those services and the services, the ecosystem of services that would draw upon them. So and this is actually the same architecture as Bob Grossman's data commons architecture. This is not actually the Death Star, but it's, though it looks like it, it's actually from, again, this Turning Fair into Reality document from the European Commission, which talks about digital objects, identifiers and metadata associated with digital objects. So I just point that out because we talked a lot about data, but actually the original fair idea is around digital objects. And now there's an awful lot of activity generated around fair software, fair workflows, fair other kinds of things, fair standard operating procedures, all those kind of other aspects too. I also wanted to do a few shout-outs to some really important people in the fair world, and at least three of them are in the room. So, Mark has been mentioned extensively with his evaluator. I don't know if you all knew that Mark was here. Here he is. Yay! And Susanna with Fair Sharing, and she's here as well. So there's some really important. Marianne Martone is instrumental in getting FAIR into neuroscience. Okay, so those FAIR principles in that paper, of which they were all authors, including me, these are the FAIR principles. They're in a breakout box. Oh, Nick's here as well. You were an author as well, weren't you? Oh, okay. Well, there we go. You should have been. They're in a breakout box. They're not actually explained in the paper. They're in a breakout box. I don't even know what the brackets mean in the metadata business. It's not gospel, right? It's not, I don't know if you're familiar with Monty Python's Life of Brian. We've decided that everything should be fair, but it should be this. No, it should be this. You are a heretic. Burn him. No, it's not gospel. And beware of fair zealots and fair disciples, because the idea was to kind of stimulate the community. They're principles, not precise practice. And as soon as that kind of release of the FAIR ideas paper, we then began a whole series of papers kind of saying, okay, so we didn't quite explain that. So here's some quotes. The latest paper in the Journal of Data Intelligence, interpretation of the derived guiding principles for implementation is far from straightforward. The proposed implementation of these principles is beginning to raise concern and confusion. These are the people who actually wrote the original papers. And Mark, who has worked extensively in trying to do this in the practice, FAIR is non-trivial and domain-specific at anything other than the most superficial level. So this is FAIR mythology summarised, and I'm going to go into some of these aspects. It's a journey. It's aspiration, it's ambiguous, as in the history of it and where it came from. It's a spectrum, it's not one thing, it's not you're fair or not fair. It's just a small part of the indicators. It's a framework for promoting organisational change. It's not a standard. It's not one size fits all. Not synonymous with open. It's not in tablets of stone. So I shall explore some of these, but with some more dressing around them. So we're in a second wave now, and all these journals are running special issues on papers explaining what FAIR was the first time. So we've created ourselves a nice little industry in the academic world, and it will do our H indexes no harm at all. So let's go back and think about why and what of FAIR, and why did it kind of try to get why did it get this kind of traction, so that we can try to understand where it came from. So where did it come from? Where was its influences? Well, its influences were around flow of information. And I'm using here Josh Summer from the Cordoma Foundation. I use extensively his idea. He had cancer, and he had a very rare cancer. One of the things he proposed in 2011 was, the trouble was, different laboratories, different research groups, different parts of a pharma organisation would work, but they wouldn't move the information. There was no information flow. And the information flow that did exist was too slow, and it was too difficult to interpret. So if you did get hold of the data, you couldn't understand it anyway. So this was, how do we improve the flow of information across collaborating and yet competing groups, where those groups have churning membership? So because the people in the lab are constantly changing, the people in the pharmaceutical companies are reorganising every 18 months. In my experiences, I think it's Eli Lilly now reorganising, but in effect, open facts, our pharmaceutical companies reorganised 3 times during the lifetime. So the flow across all of these different organisations, across projects, across communities, but also flow across technical infrastructure, between repositories, between registries, across platforms. It was all about reducing knowledge loss. That was one of the ideas. One of the things I want you to, if you only remember one thing, remember this one, because this is a kind of the world that most researchers actually operate in. Now, as a university researcher, I operate in the world where I'm running things in my lab. There's this public commons, like the UBI or the Elixir resources, which will be the final place of deposition of data for long-term archiving. But I also operate within my own organisation. I operate within my university sector. And I have to agree with their data management activities, their FAIR activities, if you will. And this actually has a far greater influence on my behaviour than this, because this is where I get promoted. This is where these are the things actually deal with me in my everyday use. So when we're talking about our everyday work, so when we're talking about FAIR, we're talking about FAIR at this level, at the researcher, at the boots on the ground actually doing the research, which is your company scientists, your researchers, your postdocs in the university and so on. We're talking about FAIR at the global level, which is how do we, as a European infrastructure, enable us to share data across data collections generated by various different organisations in different, different areas. And here we're talking about organisations. This is kind of this is kind of where we're often typically working with in European projects. How do we get the researcher to use this big infrastructure that we've developed? This is what they actually have to do, and this is crap. So it's kind of, it doesn't really develop. But without this, we can't really understand the flow of FAIR information. And who is judged FAIR? Is it here? Is it here? Or is it here? Quite a lot of the FAIR judgments that we're getting are around, is this data set, is this data repository FAIR? Well, it's only as fair as its content. If you're Zenodo, you can't accuse it of you're not fair because you don't adhere to interoperability standards, because it's not supposed to. It's there to be, so you can find things, a bucket, so you can find things and you can access things. It has nothing to say about whether the data adheres to a domain-specific standard so that you can interpret it as a biologist. So you can't say you're not fair because it's kind of is a not fair analysis. This is also why somebody has said earlier, do I need global identifiers? Yes, you do. Because if you're going to move data around, global identifiers that are unique are important. And if you just generate lots of identifiers here and lots of identifiers here and lots of identifiers here, you're making this quite difficult to move around this space. So we also have here an issue to do with responsibility and accountability of the different players here. If you're a researcher, you should be responsible in a partnership to do good data management and to prepare to share and to adopt standards. If you're a repository or a resource of some sort, say an Elixir type resource, you should have responsibility to provide persistent identifiers, to provide machine access, to future-proof your formats. But there is responsibility at all places in this triangle, and the responsibilities are different. So I wanted to highlight this. And I also wanted to highlight the fact that here you're talking about, if you're talking about the open repositories or open archives, you're really trying to figure out, well, they have different properties to things that are private. So if you're in a public commons and you're a public good, then the beneficiary is disconnected from the creator of the data. The beneficiaries are outside the organization. Oops. There we are. And interoperability drivers are quite speculative, and trying to work out the return on investment is really tricky. Is it worth it or not? Whereas at least if you're in an organization, perhaps in a pharmaceutical organization, it's more like a club, where at least the beneficiaries could be inside the organization, and in principle, the beneficiaries could be connected with the data creators. Could you enforce reciprocity, which is actually, if I make my stuff fair, will you actually cite me, or will you give me credit, or will I get value out of it? Or is it a complete disconnect? And you can at least identify interoperability drivers through your competency questions, and perhaps the return on investment is calculable. So when Helen's dealing with what's the value of her supporting, when she's supporting deciding, should I make one of my EBI public data sets fair or not, she's operating at the top level. Whereas if you're in a pharmaceutical company, you're operating at the bottom level. So it's important to understand, I think, where you are in this particular world. Okay, so what are the influences on FAIR? Rifting off that, well, here are some influences. And I wanted to particularly explore three of them: team science, open science, and automation. And I put reproducible science to one side because it's such a complicated topic it takes ages to talk about. Okay, the first is team science, and as you've already probably guessed, I'm alluding to this, collaboration is made up of individual effort, individually rewarded. That happens in research, it happens in universities and academia. I speculate whether it even happens within big projects and amongst company scientists. So this means, the I in FAIR means I want to find, access and reuse your data. So it's really important to think of the social context you're trying to incorporate FAIR into, particularly if you're going to develop incentives in order to be able to participate. The second thing is open science. So open science itself is was very well established, very well developed. There've been over 15 years of activity around open science. Here's Science as an Open Enterprise, published in 2012, where data should be accessible, intelligible, and reusable. Now you can see why FAIR made a difference. You can't even say it. I can't even say this. By the time you've got to the third syllable, a minister has kind of got, whereas you could say FAIR, oh yeah, can get that. And that's anyone, anything, anytime. So this is was one of the major influences. And over a decade or more now, 15 years, 20 years or more, we've been working on data sharing, around fairness, around activities to do with data citation, to do with publisher and funder policies, explosion in registries and repositories, data management planning, as Eric points out, and data management planning, by the way, Eric, operates at all three of those levels. The global, the public, the personal, and the enterprise level. The same old concerns, really slow cultural normalization. So we're still getting, you should work openly, sort of 15 years after these discussions. And this is partly because if we look at where did open come from? Open came from a driver from the bottom, which we might call the Republic of Science, in Morton's normative view of science, and the regulation of science. So it came top down and it came bottom up from communities. The bit that's missing is the institutions, the regular researchers, the middle management of your pharmaceutical company, right, who actually have to action this. So you've got people saying at the bottom we should do this, you've got people at the top saying strategically we should do this, but in the middle you've got people who are middle management, if you will, who say why and what's the value proposition for me. Also, I would also point out that from the point of view of the top funders and other regulators, their driver for FAIR is different to a driver for FAIR by researchers. It's to do with capitalising on investments, accountability, compliance, competitive advantage, and so on. So open science is still a interesting activity. I'm sure you've all read the Data Parasites paper. There's a Data Parasites Award every year to the best paper which used somebody else's data. It's called the Parasite Award. There's data flirters, which of course is, you can look at my data, but if you want to look any more, you have to take me on a date or put me on your paper, which is it. They're sharing spirals, understanding that people share with immediate partners and colleagues, but they're much less likely to share with people they don't know. So there's an enormous amount of sociology around data sharing. And of course, one of the things we want to try to explain to people is that making your data available so that other people can use it through sharing is sharing with you in the future. But that's quite a difficult story to tell. So that's not a public good sharing, public good fair story. That's a private productivity story. And private productivity stories actually tend to get a bit more oomph than long-term promises of general public goods being better, So that's the kind of angle. I used to believe in carrots. So I used to believe that if we created data citation and we encouraged people, they would do all of this, and I now believe in sticks because that's not going to happen. Yeah, unless you have a stick. Perhaps if it's a big carrot and you can use it as a stick. Perhaps that's the technique. Big fat carrots being used as sticks. And I think quite a few of us have come to believe that. So that says, how are we going to enforce FAIR? So what this comes out with, FAIR is not the same as open, because we wanted to promote responsible fairness. There were reasons why things shouldn't be open, like GDPR or intellectual property or crossing domain and sovereign boundaries for sensitive data and so on, but also because of jumpy PIs and deans, jumpy researchers. And we wanted to promote adoption, but this kind of rewrote sharing, open sharing, to really be retention, community of practice retention. The third driver that I wanted to mention, the impact on FAIR was automation, because FAIR principles are all about machine processable metadata. So this is automation at scale, so for data at scale. So AI, search, data mining, workflows, and so on, that unless we had machine processable metadata, it would be hard for us to scale out compute. And I've put some examples of workflows from Rob Finn's lab here. And also the rise of machine processable markup and self-description techniques to be able to do that. So I've used some of Susanna's excellent icons here about checklists and persistent identifiers and formats that were all in a machine processable way. And we went from the semantic web to linked data to knowledge graphs. It's all good knowledge graphs now. And of course we had some history on that because Barrand and many of us who wrote the paper were on the Open Facts project, which was all about creating actually a data warehouse of linked data in a fair way, if you will, though we didn't know it was fair at the time, so that we would be able to do one-off data cleaning and be able to present data so that the community will be able to use it in an interoperable kind of way. And of course what we hit was licensing problems and identifier and concept mapping problems, which is why they feature so highly in the FAIR principles, because we came across all these problems. But FAIR is not about harmonizing all metadata to one schema or publishing everything in RDF, which is Resource Description Framework for those of you who aren't in the semantic web world, or Reality Distortion Field if you're not. And I can say that because I'm actually running a track at the Semantic Web Conference, so I'm deeply in this community. But I know it's not the core thing. Interoperability requires a purpose. It's difficult and it's costly. It's interesting to see that it was so high up on the list because it's really hard. I think RDF is a red herring. Okay, I think it gets in the way. This is a survey from Nature of over nearly 800 researchers, and this is interoperability. Which of the FAIR principles needs better definition? Interoperability. People don't understand it, as was earlier said. So I think that's important. And feeding off that in Elixir, we've been really promoting this notion of lightweight markup of a few common terms that was little semantics everywhere. So we would use schema.org, which is a industry de facto standard, to mark up with a few terms, web-published resources, that could then be harvested and used by aggregators and registries and so on, so that you can reduce the 91 dataset properties that are described in schema.org to 5 that everybody would agree to, including what's the identifier and what's the license, so that you could, for the first time, say, of a dataset, you could look at the license in a machine processable way and know it when you're about to execute your workflow. And here, everything's moving towards schema.org, JSON-LD, GraphQL, knowledge graphs, out of the Sparkle RDF world. FAIR is not, here's a little bit about what FAIR is not. It's not about a resource's quality or impact or scientific value or business value. And we've had quite a lot of that today. Hence the CMM, hence the dataset prioritization, hence all the discussions about cost-benefit analysis. And this is just the core data resource indicators that are used by Elixir for choosing data sets. And the arrows point to things which are not about the FAIR principles as they were written. They're about other important indicators of importance around a data set. It's not, as we've said, in or out. It's actually like PACMAN. You know, who remembers PACMAN? Who's old? Hooray! Right. So you used to go through these little levels and you used to eat up and collect and you went to the next level, then you ate a load more things and you got to the next level. You didn't go, I have to do everything and then I get to prize. You accumulated levels. You moved between levels and you accumulated points, as it were. So it's a bit like that. You use a spectrum of indicators with different levels of maturity, with different importance to different players, hence the CMM that we're developing. And you're going to have a mixed FAIR data portfolio at different maturity depths in your organisation. But this requires, as Eric said, communities to define their levels and depths, and he called it a profile, implementation profile, and to develop just-in-time incremental delivery. So thanks to Wei for coming up with that. So fairness does not mean everyone gets the same. Fairness means everyone gets what they need. So that's quite different. So the digital repository view is quite different to a data steward's view. Well, a bit related. It's very different to a research scientist's view. I remember Paul Kersey being incredibly angry that he'd had a data set rejected. I can't remember the exact details, which is probably good if it's videoed. Because he'd failed to include one piece of metadata that somebody in a digital library really wanted, and therefore they said it was poor metadata associated with his data set. The fact that his data set had excellent scientific data in it, and this piece of metadata was utterly unimportant to anybody really doing the science, was neither here nor there, because to that librarian, it was really important. So one has to be really careful about what one means. And this is why in reusable it says metadata are richly described with a plurality of accurate and relevant attributes, because you're going to have different views on them. So FAIR is not one size fits all. And this is Baron's slide. For a fair selection, everybody has to take the same exam. Please climb that tree. That's a bit unfair. And this is why, in FAIRplus, we have this score. The score's dodgy. Don't think about the score. Think about looking at the indicators. You have to drill down to see what was being measured and what was actually important to that data set. Because if it's got 80% and actually it was irrelevant whether the thing was being evaluated for interoperability because it wasn't that kind of data set, then this is a 100% score, not an 80% score. So I'm not saying that specifically about that, but just the general principle. So here's the issue that when we came up with the idea of the FAIR principles, Mark and others were thinking of this as a contract, as a way of expressing expectation setting and self-evaluation reporting the intentions of the data providers, and perhaps within a community, organising how their information is exchanged for comparison and review and quality for something to be compliant against. It wasn't really our intention to create the FAIR police with judgment and regulation associated with it, where we will now go and immediately decide on what is meant by fair, and then we're going to publish those, what we consider to be fair. And this happened almost immediately the paper was released. That people suddenly said, okay, we have decided we are the judgment and regulation. This is what we decide fair to be, and we have decided that your resource is this fairness, which creates enormous difficulties, because then if you publicly say this data set is not fair and there's a funder in the room, well, that's transparent assessment is absolutely fundamental. So you cannot shortcut community appropriate profiles, as Eric put it, and we have to have credible and responsible assessment. And this is why I strongly disagree with one organisation being responsible for FAIR, because of this. Because it's dangerous. Because not everything that can be counted counts, and not everything that counts can be counted. So this is absolutely essential. The Tyranny of Metrics here. I don't know if you've read The Tyranny of Metrics. It's really a good book to read. Okay, so coming to the end, where do we actually have then in our FAIR world, where we've developed a FAIR profession, as it were? We talked a lot here about detailed implementation of FAIR, and you can see as you go from fuzzy, FAIR, it's a great thing, like love, down to this is how you actually annotate something with this particular ontology, to the detailed implementation. This is the spirit, this is the actual specific. But we've talked a lot about how to scale this. This detail thing is quite hard to scale. I can see a profession developing that's clarifying what is meant by FAIR and enabling the scale up and scale out. But in the middle, we have to have practice by mortals rather than super experts. So if I go to a researcher and say we want to try to improve fairability in your laboratory, they say, well, what does it mean? Isn't that just a data repository manager's job? How do we actually do it? Does everything have to be fair, which is one of the things Helen said? Should I bother with legacy data? How do I resource it? If I make the effort, how will it benefit? So this is hard for mortals. In particular, we all know that we have, if we're no longer doing legacy, but we're doing upstream FAIR, we're moving FAIR into the point of actually acquiring data, FAIR from the first, that's a leaky data pipeline. You have rubbish data, you have handy data, but not what you were looking for. You have the data that you've processed and combined with other things. You've got the data that you actually published or you decided was going to go forward in some way. That's a leaky data pipeline. What's the metadata pipeline? So we have to really understand, if you're going to really do FAIR from the first upstream, it's not just necessary to develop our FAIR verification pipeline, but it has to match the data creation pipeline and the challenges of the research which researchers are undertaking in order to be able to operate that pipeline. Otherwise, it's impossible. So we need support for metadata collection through the research workflow. And we have to think differently for standardized production versus customized exploration in that pipeline. Because if that's a standardized production, then you can predict it. But if it's exploration, that's a different kind of research pipeline. So this made me think of a business model developed by Darren Green at Harvard University Business School, where he said, okay, you can have different strategies, but in order to execute your strategy, your strategic decisions about making things fair, you need to have 4 things that have to operate all together. Process, metrics, which I will rewrite as indicators because I really don't like the word metric, culture, and organisation. So you need to have all 4 of those done at the same time. If you don't have the sensible indicators or metrics that actually are culturally make a difference to the culture or the culture will accept, then you're really stuck. So an example is if, as the University of Manchester, I'm encouraged to do interdisciplinary research, but I'm only rewarded if I do monodisciplinary research. So the strategy is I should do interdisciplinary, but actually the reward is mono. So what am I going to do? So that's because the strategy is not compliant with the actual processes of promoting the organisation's understanding of what we're trying to do and the metrics around it. We need lots of examples to copy. So lots of people are putting up, here's a pipeline. Nobody reads a spec. Nobody reads a spec. They look at an example and they copy it. So we need examples that are canonical examples we can copy. We need templates we can copy. We need to get over the overthinking analysis paralysis of if it was all perfect and we completely understood all the ontologies and everything, it would be perfect, so we would just do it. We would be able to do it. That's a challenge. And there's also the challenge we've also found in the discussions today of the disconnection between providers and consumers. If you actually don't have access to the people who own the data and generated the data as a consumer, that makes it quite hard. And there was another interesting comment. Assembling a fair mixed skills football team, I think somebody said. You do need a football team because this is a process with people associated with it. So luckily, there's been a whole emerging collection of papers and ideas around practice by mortals. And here's my 5 areas of practice by mortals, which is develop a data management plan, so that'll please Eric. Get some skills in your team, which we heard earlier. Stick your data in at least a data catalogue so you can find it, which will please Tom Plasterer, because that's what he worries about. Get some expert help and annotate and document for strangers. So that's basically, you know, and you can kind of, if you can kind of follow those, it's a bit loose, a bit fluffy, but at least it's tractable. Because the reality of verification is this. It's not linear, it's this woo. Because the reality of research is this, right? So verification will follow the same whirly stuff that we do on this roller coaster as the research does. Oh, and this is also, is fair one shot? This is from GSK. This picture says, here's the standards, and here's my data, and none of the standards fit in the data. Because it kind of presume that you have the standards for the data, and it also kind of presumes that once you've done it once, that you don't have to do it again. But as we heard from Cosmic, that's not true. You know, you need to be able to use different, revisit for different consumers. So this is where you end up in this kind of, you know, researcher misery with the baby. So what's the future? Well, this is the future from the European Commission that says this is our roadmap for those of you who are interested. We need to sort out the concepts, we need to set up a culture, we need to build a fair data ecosystem, we need to get some skilling, we need to make everybody do it through incentives, and we need to get some money, because as Bryn said, FAIR is not free, it's actually quite expensive to maintain, to do in the first instance, and then to sustain. Here's a data provider picture from the Centre for Open Science, which says you need to define what we really mean, so it's obtainable and understandable. We need to build the infrastructure and the stewardship skills. Yep. We need the policies. Yep. We need incentives and community normalization, and we need to think about the user experience. So it's back to people again. So we talked quite a lot today about this, and we talked quite a lot today, or have in the past, about this. But this bit is essential. How do you make it so that it's normative? And how do you make it so it's feasible? So for me, those are absolutely fundamental. So how do I think we should do that? How should we change those behaviours? And as we know, there are only 4 behavioural changes in the world, way to affect anything: love, money, fame, and nudge. Those are the only 4 things you can do if you're in a commons production environment. And for FAIR, you're in a commons production environment. That's what you are. So love, of course, is what PhD students do until they become faculty, and then they stop that. Fame is citations, or it's your project in your, or you get a new drug out. That's money as well. Money is grants. Nudge is what are the subtle points that we need to push change behaviour rather than doing explosion. And so here are 3 nudges. Here's a nudge in a sharing platform I know about, which says, when do you want to make it accessible to the public for citation? It doesn't say, when do you want to make this data shared? It says, when do you want it to be citable? And notice it doesn't say never, right? So you can't choose the never option. And it also says, everybody else says this one. So this is guilt tripping. That's what nudge does, is guilt trips. It's stealth. Bioschemas is a nudge technique because it's using something that's well-known, schemas, and then just uses it a bit more in order to be able to create the infrastructure for marking up data sets worldwide in order to be able to be discoverable. I've developed a tool, and I know that Susanna's developed something similar, where you basically create enriched spreadsheets, so they look like spreadsheets, but actually they're richly annotated ontology objects masquerading as spreadsheets. And then you can rip out the metadata, but it's like a nudge. People don't know they're doing that, they just think it's a drop-down box. These are nudges, right? So here's my future virtues, my future of FAIR. First, lighten up on the principles, guys, and remember they were devised in pubs. We need community-defined fair enough, so we need to simplify. Second, we need to actually build value in the organisations that the researchers actually work in, or your scientists actually work in, or disintermediate, which means eliminate them. right? You just go straight to a public cloud directly. Third, there will be a rise in a fair profession. And we will have to produce methodologies that scale with toolkits, templates, and examples that people can copy. And the Fair Digital Object Framework will be implemented using today's conventions, not a new internet. And lastly, we will have selective fair data islands with bridges between them, and we will manage upstream FAIR, so putting FAIR into the whole practice of the pipeline of data generation in a workflow, in the researcher's workflow, via libertarian paternalism. And libertarian paternalism is nudging. It's actually persuading people to do things when they don't know they're being persuaded to do it, to change things. And so, in conclusion, the best way to predict the future is to create it. FAIR inherits all the properties of team science, of open science, of the challenges of rich semantic descriptions. So we have to learn from that. It's a means to an end, not the end in itself, so lighten up. And don't fret about it. Just do something a bit. If you did a little bit, helping a little bit is helping a little bit. So I think we need to get over our fretting about that. So thank you to these particular people who helped with my slides. So thank you very much.